All right, what we're talking about today are variables, getting us started with two types that we're going to discuss today. The two types are discrete and continuous. Now we've done continuous, we've done continuous random variables. So when we're talking about this, we're not just talking about variables, but we're talking about random variables. That is things that occur. They don't occur randomly, but when we're selecting them, there are things that when if we assume that we select something at random, this is how they're going to happen or occur. Or when I get to some examples, it'll make a little more sense. But when we're talking discrete random variables, continuous random variables. Continuous random variables are things like time, things that happen with an infinite number of possible outcomes. And when we've done this, the most common continuous random variable function that we've used so far is the normal curve. All right. With discrete, we can't put a curve on it because discrete random variables are things that are countable. Like when you look at how many kids are in a family, if you have a family of 7, how many boys and how many girls? You're going to have, it can be 0 up to 7 girls if you have a family of 7. So it's something that's countable. All right. Now, when you're doing it as well, for a discrete random variable, we're going to talk about having a probability distribution. If you see the words probability distribution, what I want you to think is think of the word table. We're going to make a table. All right. So again, going back to my little example, if we have, we'll call it for C, for lack of a better word, children. If we have a family of 7, and we say, well, what's the likelihood that they have, so probability of C, number of children. So C is the number of children, let's let C be the number of girls in a family of 7. So the fewest number is 0, then 1, 2, 3, 4, 5, 6, 7. All right. And then my probability distribution would include the probability of any one of those particular events happening. All right. So what's the likelihood that in a family of 7 you have exactly 0 girls? And then we would find that number, and let's say it's 0.07. I don't know what it is. I'm not going to calculate it out right now, but I'm doing this just as an example. When we look at this, if we then take a look at all possible outcomes, so this is a list of all possible outcomes. I have 0 all the way up to 7 possible outcomes. All right, the probabilities of each of those represent the probabilities of anything that could happen. You can't have fewer than 7 girls if you have 7 children. You cannot have more than 7 girls if you have 7 children. So all of those probabilities are all the possible outcomes probabilities. If we add them up, if we add up all those probabilities of C, they add up to 1 because it represents everything. It's 100%. And that's a probability distribution for a discrete random variable. All right. So you'll be asked questions like, is this a probability distribution? Well, you look and say, first off, are all outcomes listed? Is this everything that's possible when you're counting number of girls? If the answer is yes, then I'm like, all right, I'm halfway there. And then you look and say, do the probabilities all add up to 1? If the answer is yes to both, then what we have is considered a probability distribution. All right, here's a probability distribution of spell checking software that catches non-word errors. All right, so let's say that you're going to do something and you're asked to write a 250-word essay. And what I have here is the number of possible non-word errors that were made. All right. So the fewest was 0, and the most non-word errors made were 1. And we look to see, is this a probability distribution? So I'm checking, do they all add up to 1? So I've got 0.1 plus 0.2 plus 0.3, so that's 0.6. Plus 3 is 0.9, plus 1 is 1. So I have a probability distribution here. And all the possible errors made are 0 through 4. All right. So my question would be, like, if let's say you pick a 250 word essay at random, how many would I expect, how many errors would I expect there to be? All right, so that's called an expected value. All right, with the expected value, that's the same idea as what's the average? What's the average number of errors that I see happening? All right, in a probability distribution, there's a formula for it, and it's on your note card, and it is equal to the sum of x times the probability of x. All right, so I take each x value. In the first case, I have 0, and then I multiply it by its probability, which is 0.1. The capital sigma means I add, so I'm going to add the next thing, and the x value is 1 times its probability, which is 0.2. And then I'm going to have 2 times 0.3 plus 3 times 0.3 plus 4 times 0.1. Multiply all those together, so I'm going to have 0 plus 0.2 plus 0.6 plus 0.9 plus 0.4 for a grand total of 2.1. So on any given 250 word essay that I select at random and I count how many errors there are non-word errors, on average, I would expect there to be about 2.1. And some of you are going to say, but that's not a whole number. How can you have 2.1 errors on an essay? Well, the answer is this is an average. Again, if I were to repeatedly do this, take out a 250 word essay, read it, look at it, and count how many errors there are, and then put it down, and then pick out another one at random and do the same thing. If I were to do that many times, on average, there will be about 2.1 errors that I find. All right, so that's the average. The standard deviation is not something I ever want you to really calculate by hand. We can, the formula's on your note card, but here's what I'd like you to do. In list 1, I want you to put all the x values, 0, 1, 2, 3, 4. In list 2, put the probabilities, 0.1, 0.2, 0.3, 0.3, 0.1. And then on your graphing calculator, you're going to go stat. You're going to go to calculate, calc, and you're going to do 1 var stats. And then on your home screen, if it says 1 var stats parentheses, you're going to do L1, comma, L2. Hit enter, and it will give you the standard deviation. Remember, sigma of x is the standard deviation. And then you can find the standard deviation of this. What does that mean in context? Standard deviation is the average distance of every data point from the mean. So that means if I were to pick an essay at random, I would expect it to be, on average, about this far away from the actual mean, which is 2.1. All right, so that's how much I'd expect to be away, on average, from the 2.1. So it's my average number of word errors away from 2.1. So there's bringing in context to what's going on. So that's the mean and standard deviation of a discrete random variable. Oh yeah, don't forget, one last thing. This sigma squared has its own name. All right, it's got its own special name. We're going to talk about it a lot more. I want you to see if you can find that, figure it out, look it up. Sigma squared of x has its own name. It's just a single word. It's the something of x. Write that in the reflection response for your answer. There's no other problem to finish, but do that and fill that out, and we'll see you in class. And until then, well, that's it.